So we're factoring quadratic trinomials where a is greater than 1. Okay? And to explain what that means, if you take a look at this example we have down here, this is the first time that in the x squared spot we're seeing a number, because usually if we just write x squared, right, the number that's sitting here is 1x squared. And everything we factored so far we've done when there was a 1x squared. So this is the first time we're seeing ones where there's an a value, right? We call this a because it's in the x squared spot, right? And we're saying a is greater than 1. So in this case, it's 5, right? And so when we see that 5, we're going to actually say that this has to be factored in a different way than when a is 1. Okay? And so for our purposes, you're going to hear me refer to this as AC factoring because you're going to see that we actually use the a and the c values. They're a very important part of this factoring method. Okay, so at the top we're saying AC factoring is used when the quadratic trinomial has a number in front of the x squared, and that number cannot be removed by GCF. Okay, so you saw some earlier where you could GCF, take away that front number, and then use what I'm going to again refer to as the simple factoring method, where we can do it in one step. Okay, so the goal of this method is to turn this 3-term expression into a 4-term expression, because we already talked about how you factor 4-term expressions, and we use the grouping method for those. So in this case, what our goal is going to be is to take this middle term, in this case the 11x, and we're going to try to split it up into 2 terms. So for example, 11x could be 5x plus 6x, or it could be 4x plus 7x, right? And we don't know how to split it up yet, right? But we have all these possibilities, right? We could say 2x plus 9x. Right? And so by taking 11 and splitting it up into 2 parts, this thing would then read, for example, 5x squared plus 5x plus 6x plus 2. Right? So we've turned it into 4 terms, and then we can just say, oh, I know how to do the grouping method, and we're going to use that to help us out. Right? So really this lesson is about how do I split this 11 into 2 different terms. Which ones do I use? How do I know? Right? And I call this the AC factoring method because how we know is after we check for the GCF, which I'm looking at this, I'm saying 5 and 11 and 2, well, they don't have anything in common. There's no x's in common, so there's nothing I could remove from this expression. After that, what I'm going to do is I'm going to again say this is a and b and c. I'm going to multiply together a and c. So in this case, 5 times 2, right? And that's going to give me a 10. Okay? And then I'm going to compare that with b, right, which is 11, and my goal is going to be to find a pair of numbers that multiplies to AC, which remember is a multiplied with c. Right? So I'm looking for, in this case, numbers that multiply to 10, and those same numbers have to add up to 11, which in this case, those numbers are 10 and 1. Right? So this 10 and 1 is going to tell me how do I split up 11. Well, I'm going to split up 11. Instead of writing 11, I'm going to write 10x plus 1x. Right, which I can just also write as x. Right, so I'm going to get rid of this, and in its place put 10x plus 1x. Right, so I've used a, c, and b to figure out how to split up that middle term. Right, and we're going to do that on the next step. So if you're going to notice, this step right here is going to turn into 10 plus 1. So instead of 11, I say now, because of this process here, the way to split up 11 is into 10 plus 1. Okay? And then after we do this, now I see a 4-term expression, and after this it's just let's use the grouping method. So I'm going to group the first 2 terms and the second 2 terms, and I'm going to do the grouping method. So if I'm looking at these 2, I see a 5 and an x in common, and in the second group I don't see anything in common, but remember everything does have 1 in it. So in this group I'm just going to remove a 1. Okay? So we're going to proceed just with the grouping method, which we've seen in the past. Right, there's my grouping. And then I'm going to pull away that 5 and the 1 from each of the groups. And I'm going to look and see that the second remaining term in each of them matches. And then that's going to allow me to split up the factor. So you can see that now that I've regrouped 5x plus 1, well, that goes into a group together. And x plus 2, well, that's going to go into a group together as well. So we're going to take a look at a second example and see if we can apply this. All right, so again, here's my example. I have an a value here that is not 1. All right, so I'm going to have to use this method. If there was nothing here, I could try to do simple factoring like we've done in the past, but we have to use AC because of that 3. So again, I'm going to come off to the side, and I'm going to say, in this case, my a times c, well, that would be 3 times negative 15. Well, that's going to be negative 45. Okay, and then my b value, the one that's in the middle, is 4. So my job is, let's try to figure out numbers that multiply to negative 45 and add up to 4. And if you go through the process of looking at factors of 45, you're going to find out that if I use 9 and I use negative 5, 9 times negative 5 gives me this number. 9 plus negative 5 gives me the 4, the b value. So I'm going to split 4 up into 9 plus negative 5. Alright, so I'm going to say that this turns into 3y squared plus 9y minus 5y minus 15. Okay? And now I'm going to use the grouping method. So we're going to start off and I'm going to say, let's group these first two. Okay? And I'm going to say I see a 3 and a y in common. And it looks like I'm left with y plus 3. And my second group, both of these terms in this second group here have a negative sign, so I'm going to pull out a minus. And it looks like a 5 is the only number that they have in common. There are no y's in common because this second one doesn't have a y. And then I'm going to say, well, that leaves me with y plus 3, which is good because that's got to match the y plus 3 here. So now I just need to regroup, which means take my two GCFs, 3y minus 5, okay, and then repeat the repeating factor, y plus 3. And I'm going to say 3y minus 5 times y plus 3 would be the two factors of this expression.